Hey everybody, welcome to video 2 for the cumulative review packet number 5, and we're going to start here with numbers 8 through 10, which is about finding the limit this time when you're approaching infinity or negative infinity. So what you're somewhat thinking about, the video that related limits to the asymptotes, is kind of think about asymptotes, specifically horizontal or slant come into mind, like the bottom heavy, top heavy type thing. If we look at number 8, we want to know what the limit of this function is as x goes towards positive infinity. Now, what I'd like you to notice without factoring or anything else is I want you to notice the lead terms on the top and the bottom. This function looks like it is quite bottom heavy because the highest power in the denominator is 8 and the highest power in the numerator is 2. So picture plugging in infinity or a very large number on the top and the bottom if you ignore the rest of it except for the first terms. Think about it. Is infinity to the 8th going to be bigger or infinity to the 2nd? Well, infinity to the 8th power, that 8 and that 3 really don't matter. This is going to be so much bigger than the top. If you simplify it, think about even if you take a number like 1 and you would divide that by infinity. What number are you getting really close to if you take a small number and divide it by a large number? Well, you're getting really, really close to 0, which means that my limit as x goes to infinity would have to be 0, because this would be going towards 0, something like 1 times infinity would be going towards 0. So if this were an asymptote, this would be a horizontal asymptote at y equals 0, which makes sense why the limit is also 0 itself. Number 9, we don't have a rational function, but all we know is that x is going towards negative infinity. So what we could do at least is plug in the negative infinity to see what it's doing. So if I plug in negative infinity to the third plus 4 times negative infinity. Well, even though infinity is large, if you take a negative times a negative times a negative, it's still negative. So this I view is still negative infinity plus 4 times negative infinity. That 4 again doesn't really matter because 4 times infinity doesn't make that much difference. So you're really doing negative infinity plus another negative infinity. So it seems like we are still in or going towards negative infinity. So as x is approaching negative infinity, we are still in the y values are still going towards negative infinity as well. Number 10, now that we're back to rational functions, if you take a look at the first terms again before factoring, this is what I would always do when you're trying to find a limit towards infinity or negative, because we're thinking about it in terms of asymptotes. We have really 4x squared over 4x squared. If you think about plugging it infinity, if you'd like to, if it helps you, both of these exponents are the exact same, so these are increasing at the same rate. And so this is what I call that the powers are even. So whenever we were trying to find a horizontal asymptote in the previous units and the powers here were the same, we just looked at the lead coefficients on both. So if you're really looking at 4 over 4, that really reduces to 1. So that means that my limit here would be positive 1. And if this were a horizontal asymptote, it would be y equals 1. Number 11, here's where everything comes together, where we want to find everything about this function, and then we want to graph it. So graph the rational function. The reason it is written in this order is my suggestion is to find the horizontal and slant first, because these are ones you do not have to factor yet. However, after the slant and the domain down, you need to factor to find the rest of the information. So to find my horizontal asymptote, remember that you cannot have both of these at the same time. So we need to look at my function. And I notice that my function is top heavy. And whenever a function is top heavy, that leads to a slant asymptote. Now for the sake of it, I'm going to erase this so I have enough room. If I have a slant asymptote, what I'm going to have to do is the long division to figure out what that is. So now I could do long division, but because this is linear in the denominator, let's go ahead and do synthetic division instead. So we have 2, 1, 1, negative 2, bring down the 1, 1 times 2 is 2, 3, 2 times 3 is 6, and 4. You might recall that this is the remainder, and we don't care about the remainder when we're trying to find the slant. So my slant asymptote will be y equals, this is really x plus 3, so it will be y equals x plus 3. And if I have a slant, I cannot have a horizontal because a function cannot be top-heavy and bottom-heavy at the same time. My domain would be found after I factor. So in red, I'm going to take this function and factor it down here. I'm going to factor the numerator to be x plus 2, x minus 1, and the denominator I'm going to leave as x minus 2. Now nothing seems to cancel, but that doesn't matter yet for the domain. The only value that x cannot be is positive 2. So my domain would be negative infinity to 2, and then 2 to infinity. So we're done with that first piece. Because nothing crosses out, I have no holes. I do have a vertical asymptote, a one value I can't have of 2. So I have a vertical line I can't cross at 2. If I want to find my x-intercepts, another word for x-intercept is really a 0. So if you look in the numerator, I have 2 zeros because nothing crossed out. One is at negative 2, 0, and the other one is at 1, 0. If I consider my y-intercept, which is in the form 0, a number, you definitely could plug the 0 into this red function. But my suggestion, just like the horizontal and slant, would be to consider doing this more towards the beginning. I kind of wish I had that earlier at this point. Because if I plug 0 in every time I see an x, I would get 0 squared plus 0 minus 2 over 0 minus 2. And all of the zeros eventually disappear, and I'm left with negative 2 over negative 2, which is just 1. So my y-intercept is at 0, 1. So in the next example, I'm probably going to find this first before factoring. Now, before I get to the limits, I'm going to go ahead and graph what I have so far. I have a slant asymptote of y equals x plus 3. So that means if I was graphing a line, I would start at the y-intercept of 3, and then my slope is really up 1 over 1. So my line would look like this in both directions. And because it's a line I may not be able to cross, I'm going to make it dotted. Step 1, slant done. I have a vertical line I can't cross also at x equals 2. So I'm going to draw another dotted line here. I have no holes. I have x-intercepts at negative 2, 0, which is here, and 1, 0. I have a y-intercept of 0, 1. So it looks like a part of this graph, at least, would be in this section, probably looking something like this, because it has to be between the lines you can't cross, or the asymptotes. Usually, though, these things come in pairs. So my gut is telling me that the other piece of this will be up here, but to make sure, and something I would suggest for you, is let's pick an x value that we can clearly see in this region, like 4, for instance. Let's see where 4, if 4 ends up being in this region. So I'm going to plug 4 into this original problem. 4 squared plus 4 minus 2 over 4 minus 2. So that would be 16 plus 4 minus 2 over 2. So that would be 20, so that would be 18 over 2, or 9. So when I plug 4 in, my output value is 9, which means that the other section of my graph would look probably something like this. A lot of the times they're across from each other. And so this is what my graph looks like on this example. And now that I have the graph, it might help some of you. Some of you, it might be better to think of it algebraically. If I would like to find the limit as x goes to infinity, if I look at my graph now, as x is going towards infinity, what is my graph doing? Well, this blue graph is on this side, so if I look at the purple graph, it looks like my graph is continuously going up towards positive infinity, or my y values are going towards positive infinity up here as x is increasing. The limit as x approaches 2 would be, well, let's see. As x is approaching 2, if we look graphically, from the left side, if I approach 2, it looks like I'm going towards negative infinity. However, if I approach 2 from the right side, it looks like I'm going towards positive infinity here, but negative infinity here. So the limit exactly at 2 would not exist. And I'll write a note, because from the left, we went to negative infinity, and the right, we went up to positive infinity. So because they're not the same, that's why the answer does not exist. The next example, number 12, same idea. So I want to find all this information to use to graph. So like the last example, I would like to look at these two and the y-intercept this time at the beginning before I factor. So if I have to decide between these two, I notice that this is not top heavy or bottom heavy, it's even, which to me leads towards a horizontal asymptote because the powers are the same. The lead coefficient in front of both of these is 1, so I have a horizontal at y equals 1, which means I do not have a slant asymptote at all. So we had y equals 1 as my horizontal. While I'm at it, let me find my y-intercept. If I erase this so it doesn't get in the way, the y-intercept would be 0 squared. And now some of you may not even need to write this down because all the zeros make all the x's disappear. 0 squared plus 3 times 0 minus 10 over 0 squared minus 4. The zeros eventually disappear, and you're left with negative 10 over negative 4, which is 5/2 or 2.5. So my y-intercept is at 0, 5/2. Now that I found that information, now I'm going to factor, and I'll do so over here. The numerator would end up being x plus 5, x minus 2, and in the denominator, I'd have x plus 2 and x minus 2. Before I cross anything out, my x values in the denominator cannot be negative 2 or 2. So my domain would be negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. Now, I notice that the x minus 2's cross out, which means that I have a hole at 2 comma something. And again, to find that something, I need to plug into the reduced version of x plus 5 over x plus 2. So I need to plug 2 in here, 2 plus 5 on the top, 2 plus 2 in the denominator. So you get 7/4 for the y value of your hole. If I look back at the function, I do have a value that still does not exist in the denominator. So my vertical asymptote is x equals negative 2. And my x-intercept, again, aka a 0, I'm just going to cross out x-intercept because I think we've been using 0 also, but they are interchangeable. So I probably shouldn't cross it out, probably just have it written there. My 0 is what is left in the numerator, which would be negative 5 comma 0. We can definitely find these limits algebraically, but it might be good to also graph it first. Why not? So let's graph what we have. We have a horizontal asymptote at y equals 1, so it'll be here. We do not have a slant. We have a vertical asymptote at x equals negative 2, there. We have a hole this time at 2 comma 7/4. 7/4, 4 goes into 7 one time. It's probably almost 2, but not quite. So your hole would be at 2 comma somewhere between 1 and 2, a little closer to 2. So I just put a dot, open circle right there to represent your hole. You have an x-intercept at negative 5, 0. You have a y-intercept at 0, 5/2, which is really 0, 2.5, right here. So if we look at what we have, I know that my two pieces of my graph are going to be on these two sides. So you could plug in more points to be more accurate, but I know over here that we're going to go through this point. Can't go through the hole technically, but we can use it as a guider. Usually your pieces of your graph are going to get close to the asymptotes but not touch them. So this one will get closer and closer this way. I have a single dot over here, so I know that the rest of the graph has to go at least through negative 5, 0 and get close to both asymptotes. So that would be a sketch of your answer. So for the first limit, as we approach negative 2 from the left, if we use the graph, looks like I'm going towards negative infinity. So that would be my limit there. and my limit as x approaches 2, well, we already know it. If we approach 2, the y value according to the whole would be 7/4.